welcome everyone. So today we're hosting Jonathan Joyce of the RPS group, and the topic for today's presentation is debuffs processed by the system. We'll first demonstrate how users can access the raw data directly from the cloud using Python tools such as XREDS. Second, we will describe the efforts of the XPublish community to produce REST API endpoints for data access. And we will discuss why serving data through XPublish fosters data accessibility and ultimately leads to democratized cloud-based data access. I will then demonstrate practical examples of how users can interact with the XPublish APIs to retrieve data without existing Python knowledge. So Jonathan, I'll go ahead and turn it over to you. Thanks.
Thanks, Micah. Let me present. Okay, that visible to everyone?
Yeah, looks good. Go ahead and click the hide button at the bottom too, if you don't mind.
There we go. All right, so hi everyone. I'm Jonathan Joyce. I'm a principal software engineer at RPS Group. Today I'm going to be talking about reaching for the cloud, architecting a cloud-native service-based ecosystem for DMAC. And I'm the technical lead of this project. I'm going to kind of start with, for those who are not familiar with the project, kind of give a brief project overview. Then we're going to kind of go top down. So I'm going to talk about the kind of overall system architecture and our ideas there. And then we're going to drill down to our specific prototype that we've developed and that we're presenting today. And then kind of general discussion about how to access environmental data. And then finally, the bulk of the talk will be about XPublish, what it does, why you might want to use it, and why I think all of this is going to make a big impact for this community. So this has been a 3-year project, right? We're entering year 3 of this right now. So far, we've spent a lot of time meeting with our steering committee members, meeting with the IUS regional associations to kind of understand the current state of their systems, how they're delivering data, where the current pain points are. And then, of course, we've been working on the technical side as well, right? Researching solutions and testing out different technologies. The main goal of this project, it's really aspirational. It's to increase the use of IUS data. I don't know why that one changes. Increase the use of IUS data and promote connections across other disciplines. So right now, right, it can be challenging to find a forecast and be able to make use of it without having a lot of knowledge of the underlying technologies. And we really see the cloud as an opportunity for promoting that collaboration. So it's not necessarily that we have to do everything in the cloud because it's the new cool thing, but there's really a lot of opportunity there, and we don't want to miss out on that. And so part of that too is going to be, we are developing a roadmap and a proposed architecture. So not necessarily an operational system, but more a recommendation of, hey, here's the best technologies, here's the best tools available to us today, right? We don't know the future in 5 to 10 years. We know new things will come out. So we're also promoting flexibility and making sure that our recommendations will be strong going into the future as well. And then finally, on top of that, we're developing different prototypes for different kinds of data sets, demonstrating how those can be used within a cloud-based system like this. So first, I'd like to acknowledge all the work that's gone into this. On the RPS development team, Ben Adams was instrumental in looking at the workflow software and selecting the Argo Workflows, which we'll talk about. And Matt Iannucci has done a lot of work to get XPublish actually functioning and building up our demos. And Pavani's done a lot of good work in the back end. She's only been here a couple months, but has led to significant help keeping the website running. Our tech team meetings, so these are like the very technical minded steering committee members who we meet with on a bi-monthly basis. And we discuss ideas, we discuss the technology in depth, where we should go, and it's been really valuable meeting with them. And then a fairly new community, the XPublish community. It's being led by Alex Kearney, so thank you, Alex. This is a group of individuals who are all trying to solve similar type problems. We've kind of gathered around this idea of XPublish, which I'll be talking about. And so we're all kind of working in this same open source ecosystem. So on the architecture side, so when we're thinking about moving into the cloud, from a system engineering and software perspective, right, there's kind of a right way and a more difficult way to move into the cloud. So since we're kind of starting at ground zero with this project, we were looking at, well, how can we really get the most benefits, like scalability for the lowest price? How can we really take advantage of all the things that the cloud offers, such as their whole global infrastructure, high availability, and how do we make it so that people can actually collaborate on it? So for those reasons, we selected the Kubernetes platform, and it's because it's a very popular platform. It's open source and it's used in industry a lot, and it helps us with those things like scalability and cost savings. It's able to scale. People are doing way larger, working with way larger data than we are. And the other benefit is it doesn't pigeonhole us into a particular cloud vendor. So you can run Kubernetes on AWS, on Azure, GCP, or even another third-party one. So that way we're not locked in to a particular cloud vendor or necessarily tech stack programming language. And then looking on the data side, right, how can we create analysis ready cloud optimized data? So data that's available for us to access as soon as it's on the cloud. And how do we determine that and how do we ensure that it's high quality? And for that piece, we're working on Argo Workflows to run our data pipelines, because we know we can't necessarily pick a canned solution. We know that we need to customize, and that all IUS and NOAA data sets are very different. And so we know that we'll need to be able to run custom code in our pipelines. And we also know that we need something that scales, and Argo does that very well. It runs on top of the Kubernetes platform, and people are using it with thousands and thousands of workflows. And so we won't even hit that scale likely either. And so kind of an idea of what our system architecture would look like, right? You're running your infrastructure in the cloud with Kubernetes, kind of managing your instances, your scaling, security, and then all those network or system administrator tasks like maintenance and monitoring, and all that automation. And on top of that, then we run the Argo workflows, the data pipelines, where you can create these custom scripts for transforming the data, i.e. chunking it, quality and compliance. So Ben Adams did create a prototype demonstrating use of QC within the Argo workflow. And then, of course, analyzing the metadata. You want visibility into that workflow, so you're able to do that through Argo. Ultimately, that produces our data into our data lake. And then what we'll primarily be talking about today is the data services aspect, where we have things like XPublish, any custom web apps that are making use of that data. And so all of this running there and ultimately serving our customers or anyone using that data. So how did we get here? From the technical side, we really just started with a diverse list of technologies. from Pangeo, from Python, from the cloud in general. And we tested those individually, right, to really see, is this something we can use? Is this more difficult than it's worth? Is this, relevant to the problems that we're trying to solve? And I also spent a lot of time, researching system architectures. So looking at kind of the big players in this space, such as Uber Maps, right, is geospatial data serving millions of customers, right? How do they build those systems? What do they look like? And then from the analytics community, right, how is it best to organize your enterprise data and also make it available for analytics and kind of that deeper pulling information out of that data. And then we've built some CAN prototypes, kind of demonstrating the full stack of technologies before we went to our current prototype, which is we have taken the Delaware Bay operational forecast system, and we are chunking it or making it cloud optimized. We're also generating a best forecast over 30 days. We're pushing all this data to a public S3 bucket. We've added SGRID rendering support. And essentially we've developed a pattern for taking data from Nod and making it cloud optimized and being able to serve it through XPublish. So now that we kind of have that pattern, we see what we like, what we don't. Now we're going to be able to adjust that, add more data sets in the future as we'd like, and continue to scale this out. In order to make all this work, right, we had to create a lot of the back end of that system architecture that I demonstrated, right? This is all prototype work, right? This isn't a production system, but we are running all of this in our AWS account. We provisioned Kubernetes. We installed and configured Argo on that, created our workflows, did a lot of work at AWS, creating the accounts, permissions, all the resources that you need. We wrote the custom scripts to convert that data to our Czar format. And then, of course, the iteration of deploying it, making sure it works, and fixing bugs. All the configurations for this are on the GitHub site as well, which we can share. So how does this actually work? So starting in the upper left, right, we have our Nod bucket with the OFS data in it. We listen to events from that bucket when a new file is added to that bucket. It generates a notification, which puts it in our queue, which is listened to by our Argo sensor. That Argo sensor kicks off a workflow, which is scheduled on Kubernetes. Our Kubernetes cluster is running in 2 availability zones, US East 1A and 1B. So those are 2 different networks that we have machines on. So if one goes down, it can still continue to function and schedule the jobs on the one that's up. From there, Kubernetes generates a container, which runs our custom code, which generates the Kerchunk data. That Kerchunk data then goes into our public S3 bucket. And note that this is not a copy of the data, right? We are referencing the original Nod data. So it not only has data for 30 days, and so once that data goes away, right, we remove our reference as well because it won't work. But this keeps the size of the next-gen DMAC bucket very small. From there, we're repeating the same pattern. So when new Kerchunk data goes into our bucket, we generate a notification that goes into our queue, which gets read by a sensor, generates a workflow, and then that's how we create our 30-day best forecast aggregation and our total forecast aggregation. So I'll step back from kind of the system architecture type stuff right now. And so let's talk about the data, like the state today. So what are the steps you would do? I'm looking for an audience member. What are the steps you would do if you want and we can use DBOFs as an example. How would you get that today? How would you select the data you want? And then taking that further, how would you compare that to another data set? So I'll move to the audience. Any takers?
Well, if no one else is gonna volunteer an answer, I guess I'll take a stab at it. Well, so you could, there are a few different places to access, I think, the OFS output. So there's a thread service run by NOS. And also, I believe you guys would know, but there's a duplicate thread service provided by RPS through the EDS project, right? So you could, create some scripts and download some output files or a subset, perhaps through the DOD service, and then run your analysis on your MacBook.
All right, thanks, Micah.
Maybe someone else has a better plan than that, though.
Oh, I'm at the start. Maybe. All right.
But the question that you put there is a little bit of analyze. You say analyze a NOAA IU's forecast. So anyone can analyze the NOAA forecast. Only the forecaster can analyze the NOAA forecast. So are you meaning that what Micah just mentioned, where you can access the data? I mean, the forecast data, output. Is that what you mean?
Yes.
Okay, all right. I just want to clarify that, because the question was a little bit of, analyze. It's different than just access. So.
Yeah, there are a lot of different use cases. In general. Okay. Well, thanks. So yeah, I'm going to, and I was also kind of making sure for myself, was I kind of missing anything? So I'll be talking about these traditional methods of accessing the data, right? So you could download files locally, you could hit open app endpoint. If you need the best forecast aggregation, right, you need a threads instance most likely. And if you don't want to work with the data in its native grid format, right, you'd need something that transforms that into a regular grid.
Hey, Jonathan, sorry to interrupt, but I don't know, are you okay with taking questions or comments in real time here?
I could, sure.
I just wanted to give Jim a chance to weigh in.
Yeah, sorry, I was just going to contribute to what Micah and Hassan just said about accessing the data through thread services, which is probably the way most people do it. But I think one of the challenges, and you just hit on it right here, is the aggregation part. And curiously, the RAs do provide aggregations, but a lot of the main NOAA sites do not, and that's a big challenge. If you're trying to pull file, let's say you want to extract. So here's actually an example. I'm trying to extract cloud data from this NCI served ISCIP data set, and they have files every 3 hours, and I'm trying to pull out a point for 20 years, and it just does not work. So that's highlighting, I think, what you're talking about here on the aggregation side. Thanks.
Yeah, thank you. All right, anyone else? Okay. Switch screens, so hopefully now I can see both maybe. All right, so Jim brought up a good point with that. And so other options are newer methods, right? You can access the NOAA data on cloud storage directly, or now what we're providing is the Czar data from cloud storage. And the reason for this is that accessing those NetCDF, the gridded files, GRIB, from cloud storage is extremely slow. And so that's why we have this now Czar option and why we're referencing the original data with that. And then the new piece that we'll also talk about, right, is XPublish APIs. Before I go further, I just want to put out a few definitions because I probably say these words a lot. So Czar is really a specification. It's essentially a JSON file, so nothing too complicated about it. You can reference data from it, or you can actually have the actual data bytes stored in Czar format. And Kerchunk is more of the process where we take a gridded format like NetCDF, GRIB, and convert it into a Czar so that we're able to quickly read it, right? It indexes the byte ranges that it needs to read so that it's very quick in the cloud and able to also access it in parallel. And so those are the main things about that, yeah. And so now go into some XPublish. It's probably the rest of this talk. So what is it? It's essentially a framework for serving environmental data through REST APIs. And the goal of it is to work with data without having to write code, without having to understand what the file format is in, or use these different protocols, which are really only known to the science community. So by using more traditional APIs, right, will open up that access to people who might not have a lot of experience with environmental data. We want to host these services on modern web platforms, be able to scale them. We also want to combine efforts of many organizations. I mentioned the XPublish community, all trying to solve similar type problems. Almost every time someone builds a web portal, they have to do the same steps. You could think of it as it's not an API, but a series of plugins. So XPublish really takes the XRA data model and converts it so that we're able to serve that data through APIs. And so if you want to add or modify a new API, you don't need to rewrite XPublish, right? XPublish is just the platform, and you can have any number, OpenDAP, EDR, web mapping service being served through that. And for examples, EDR is like selecting points, lines, polygons of data. Web mapping service is what you'll typically see on a map website with the tiles of the data, which we'll show. There's still a lot of work to do on this project, right? We want to implement logic for the different types of grids, right? There's UGrids, SGrids, regular grids. We do need to write custom code to support all of those, which we're planning to do in the future. We have a lot of performance optimizations and opportunities for caching and scaling. And then it is pretty easy to deploy now, but we want to standardize that deployment and make it even easier. And so the main reasons why would you want to use XPublish? Like I mentioned, you no longer have to be concerned about, right, is this a GRIB file? Is this a NetCDF file? You don't even care, well, is this a UGrid, SGrid, right? These are all decisions that you have to make whenever you're working with a new data set. And so we're kind of abstracting that away. That also means that you don't need to manage dependencies and get the right binaries for your platform for NetCDF or to read GRIB. Anyone tried developing GRIB on Windows? It's kind of painful. I don't think it works. And then it's also abstracting away the language. So a lot of these tools, right, are written in Python because that's where the community has gone and that's where most of the work is done. But through XPublish, right, we're just serving data through endpoints, so you can interpret that data through any language that you might want to use, right, Go, Julia, etc. As I mentioned, you can customize the APIs as we need, and then we're able to hide the complexity of scaling and caching and storage behind the web service and be able to solve those difficult problems one time rather than for every app or website that we develop. I mentioned the community a few times, and the other big benefit though is once we're working in this XRA ecosystem, which is why we have an X for XPublish, you get to leverage all the work that's already been done in XRA in the ecosystem. There's a ton of tools built that work with XRA data that now we can leverage. So now, let's see how this, I'm going to swap over to a little web browser. So I've talked about XPublish a lot. I'm going to pull up our kind of our prototype. Okay, all right, so that looks like it's displaying. So the goal of this project, right, isn't to create a pretty website, but Matt Iannucci does this stuff in his sleep. So here's a quick, easy website. Kind of, we're demonstrating the use of XPublish. So this is the DMAC data that I talked about. You can see that we have about a month of it loaded up. You can change the times, change the time steps, the color bars, etc. I said not necessarily here to talk about the features of the website, but more how do we power it. You see our initial demo is there, and we can see the variables, interact with them, etc. So now taking a step behind the scenes now, we have, these are just, this might be kind of boring to non-developers, but I'm just kind of demonstrating. So you can hit this website, and this is public, by the way, NextGenDev, IUC-US, XREDS. I have a resources slide at the end. And so you can hit these different API endpoints through your web browser. So here in this example, we're retrieving the OpenDAP specification for DBOFs. Here we're selecting the DAS definition. Here, this is an example of like when you hit the website, right? This is behind the web mapping service. And so what this means is that really any web platform, Mapbox, et cetera, that understands how to work with web mapping service is able to simply plug into our XPublish endpoint and get tiles back to display on a map. We have, you're able to inspect the dataset definition, right? Normally you would have to load this up in Python in order to inspect your variables, but now you're able to do that through a web browser. You're able to get metadata out of the, right? This looks kind of like chaos to us, but for machine to machine, this is really useful tool where you can inspect the metadata. And you can also, list your variables. There's a ton of functions. And like I said, it's not necessarily limited to this. This is just what we've come up with so far. See, any questions on that right now?
I'll ask a quick question. So the URL you used to included XREDS as a in the path. So that's a service that's built on top of XPublish.
Yeah, sorry, I forgot to describe that. Yeah, so it gets confusing. So yeah, XREDS is our XRA environmental data service. And that is essentially, that's the front end. So that's what we're seeing here, XREDS viewer. It is using the XPublish libraries behind the scenes to serve this data.
Okay. So it's
yeah,
kind of analogous, I guess, to Threads plus the WMS, at least for the mapping part, plus the WMS plugin.
Sort of, yeah. It's, yeah, a little bit of semantics, and maybe because this is all new, maybe we should call it all XPublish. I don't know.
Can I interject for a second? So to be clear, so XPublish is like the base layer that you can use to serve up your data sets with XRA. What XREDS is basically a server, like you can customize the behavior of XPublish using plugins. And so XREDS is basically our own customized plugins for loading data sets, but then also loading ones from the community, ones like Alex has developed and I have developed and others are developing now, and putting them into one and loading them up with one server so we can do all of this stuff with our environmental data as we please. So it's basically like, you can think of it as like a distribution almost, because anybody can take XPublish and extend it however they would want to build whatever app or website they could imagine, right? It's basically, XPublish is the foundation that you can build up on top of, or you can just use it as it is if you need only the base functionality. I hope that helps clarify a little bit.
Yeah, thanks, Matt.
All right. Yeah, thanks, Pat. So I'm going to go into some ideas now. So I showed you the functionality. So why does this even matter? So one example, actually Jim brought up, right? How do you retrieve the best forecast? So right today, if you're running a thread server, you know, what do you need to do on the server side, and what do you need to do on the client side? So on the server side, right, to run threads, you need a server. You need to operate that. You need to have some sort of aggregation process. And then if you have a different coordinate system you want, right, you need to pre-process that or manually convert it. And now, right, I presented, well, we have all this Czar data up on S3, so why not just use that? All you need is an S3 bucket, so we got rid of the server. And you need a process, like I showed, we used our Argo workflow, but it could be anything that creates the best Czar file. But still, you have to deal with your coordinate systems, and you need to process that data locally. But with XPublish again, so it is a web server. We're running it. You need to operate, maintain it. You do need that best Czar file process. But now it's handling the coordinate systems for you. So that's a benefit. And so when you're using these as a client, if you're reading, you need some type of, you might use X-ray, might not, but you do need NetCDF Grib. You need a OpenDAP client to connect. If you're reading from S3, you want Czar and X-ray. You still need NetCDF and Grib because you're pulling the data down and then you're working with it on your local machine. And then you need something to be able to read S3. And so what we're doing with XPublish is, depending what you want to do, maybe you need nothing. Maybe you just need to be able to hit a web endpoint. If you want to read the Czar data, yeah, you can point to the Czar XPublish spec and pull that data down directly. And because Czar is a specification, it's really any language that has that specification. For example, there's a JavaScript Czar reader, so you can point that at the XPublish endpoint and do all your work in JavaScript if you'd like. And so example 2 for XPublish. So in my time in this industry, right, I've built, I think, a lot of the same. I built tools to get the best forecast, tools to read data and index data in probably 3 different programming languages for 4 different projects. We keep repeating the same things, I think, in different departments within NOAA. So using this just a simplified example. So let's say you want to build a website that displays environmental data, right? A lot of us do this. So what you would need, right? You need to create the website part, the front end. You'd need to be able to get that data. So you need to find where the data is that you want. You need to get it in a format where you're able to work with it. Then you're going to need some kind of pipeline or cron job or something that will keep updating that data because forecasts always change. You need to figure out how to read that data, read the grids. How do you project it in the right way for your website? Or, maybe you're doing a time series plot, right? How do you pull that data out quickly? You need an interface then from your front end to be able to get that data. And then you need all the right back-end work to make it fast, right? Scaling, let lots of users hit it so it doesn't get bogged down. So what we're saying is with XPublish that you kind of get rid of half of the work, but you still, if you just want to host XPublish, so you build your web page, you still need to find the data, right, that you want to use, get it in a format that XPublish can read, and then kind of keep that updated. But XPublish will do all of these jobs for you, read the grids, give you an API, and scale. And now taking it further, so now if you're doing a project with I use DMAC data using the next-gen DMAC, well, then what we're trying to do is kind of automate the data part as well. That was the first part where I talked about Argo workflows, and why we're doing all that is because we want to make it as simple as possible for people to use IUS data. Just create a website, plug it in, point it to XPublish, and you're done. And that's really what we're hoping to get to as we keep developing this. So in terms of the project next steps, we are going to keep working and extending XPublish to work with various grid types. Like I said, we want to work with the national water model, make that more accessible. We have a project to work on the Gulf of Mexico forecast system, which is an unstructured grid, and WCOFs, which is a curvilinear grid. So we do need to figure out how to translate from grid space to API space. We're also going to work on high frequency radar radials and sorting that data from the cloud. And then we're also in parallel working on this NCDIS 40-year reanalysis, which is more of like a data science project where we're looking at 40 years of data and then analyzing that with Dask and Jupyter notebooks and more of like a scientific study. So these are the resources you can reach. You can start a discussion if you want to talk more about this on our GitHub page or email me directly. We have a lot of project documentation kind of talking about the ideas behind this we've come up with. You can go explore the demo. You can explore the XPublish API, look at our Czar data and maybe do something with it. I've created some Jupyter Notebook examples of accessing data. I could go over after this. There's our project GitHub where we meet with our tech team every other Wednesday, and of course the XPublish community for anyone who wants to contribute. This is all open source, and I've been really excited about this project, and I think that as we keep working toward these problems and kind of building out XPublish, I think we'll see a massive positive change in how our data is able to be used. So thank you.
All right, awesome. Thank you, Jonathan. Very cool. So I guess we still have some time left. So just want to give folks a chance to ask any questions that they maybe haven't asked so far. So yeah, let's open up the floor for Q&A. Hassan?
Oh, thank you, Mike. And I just asked if we can share those slides, but I'm interested on what you said about reanalysis, the 40 years analysis, reanalysis of the. So my understanding is that, well, those NOS models, ocean models offices, they are very short and they are not doing any reanalysis at this point. But they are going to be trying also to do some reanalysis. So I am sitting with what we call Climate Fisheries Ecosystem Initiative, and we are trying to build this portal or data hub for reanalysis data, handcast, and all that thing that you mentioned for science purposes. So I don't know if you will be, and they mentioned exactly this project that you guys are working on, because I think Derek mentioned that in the steering committee for this work, for this initiative. And I think it would be helpful to bring someone to talk about what you guys are doing in terms of optimizing all this data in the cloud. Because what I learned from that group is that they are working with MOM6 reanalysis, trying to get it, and some of it is already in physical, what they call the physical science laboratory. That's within NOAA OER. And so they want to try to start with MOM6, if you are familiar with that model from GFDL, and then they want to expand to NOS. But since NOS is already doing this, it seems to me would be very important for us to already start talking to them, and then see if there is any synergies that can be built between what they are doing in MOM6 and what NOS is doing through this project what you guys are working on. Is that a long? Sorry, I've been blubbering. So, do you capture what I said?
I don't know the full extent of the NCDIS project. But yeah, it makes sense. I mean, there are a lot of groups all trying to do this same type of work and working with Kerchunk. And that is why we're trying to develop this in open source and share kind of how those processes work.
Yeah, correct. But yeah, because what I understand, sorry that I'm expanding on this, that when you are exposing that data from what you showed, it's going to be short-lived anyway. It's not going to stay there for a while, right? Is that it's not going to be archived for a certain period of time. What what you mentioned there for reanalysis, a completely different infrastructure that have to be built, and that require a different. So I mentioned that we are already doing it with MOMS. Again, if you are not familiar, that's fine. This is a global model, MOM6 with GFDL, NOAA GFDL, and they are doing it with PSL, the Physical Science Laboratory. So now, NOS is going to be doing some of this as well, reanalysis of that offices that we have for coastal, and this would be serving the climate fisheries, as I mentioned, fisheries and ecosystem initiative. So I don't know if you would be willing, or someone from this team willing to come to this these teams that we are working on to present, to talk about what you guys are doing. Because since we don't want to duplicate this effort. So
Hassan, absolutely. There's a whole team of us involved in that 40-year reanalysis project here at RPS, including Jonathan and Cheryl Morse and others. And to be honest, when we started the project, we thought we were going to use some of the traditional approaches that Jonathan went through, and then we decided to use this DMAC next-gen approach, and it's been successful beyond our wildest dreams. So we would be happy to share lessons learned in terms of all of this. It's a reanalysis data set, so as you very rightly point out, it's a slightly different flavor of what we talked about here, right, in terms of our approach and all of that, but there are a lot of things that we can apply across to it. And I would think that the one that we're working with is AdCirc. I would think that, it would be a fun test to see if we could apply a lot of that approach to MOM6.
Excellent.
But we're optimizing how the data set is chunked. We're using intake catalogs and to help us with that, especially well, it gets into a lot of details, but yeah, we will be happy to present, and probably Jonathan and Cheryl Morse that would present that together. I would
Excellent.
think.
Very good. And we don't have to do it during this summer. I mean, we can probably schedule something for September where the team mostly, last week of each month. So we can schedule something during September, October, I think. We don't have to rush for now. I mean, people are in vacation anyway.
Okay.
So I will.
Whatever you think is best.
Do you want me to just send you an email and probably directly to you, or?
Yeah, that's fine. That's fine. Me and Jonathan, we'll loop Cheryl and we can go from there. Yeah.
I will CC Micah on this. So thank you.
Perfect.
Thanks. Yeah, and I think another thing I forgot to mention though was, regardless, we did a forecast, but really any data set, once you chunk it, get in the cloud optimized format, the significance of XPublish is that then it should, if assuming it has the right grid structure that we've implemented, XPublish is then able to take that and serve that data. So we don't need to reprogram all that, right? It should just work with the services that you have.
Sounds great. Thank you. Thank you, John.
All right, so as a question from Philemon, I think is a good one in the chat. You mentioned about Czar. Are you promoting the use of Czar instead of NetCDF? So I think this gets into some of the nuts and bolts about how this actually works.
Yeah, so yes, well, yes and no. So we are not converting the data all to a Czar format. So we're keeping the original NetCDF data, and then through Kerchunk, we are referencing that original data. So you can keep your data in Czar NetCDF, but yeah, it would, for performance reasons and for being able to access the data efficiently from the cloud, we do recommend this using the Czar specification.
But Jonathan, to be clear, we understand that this community has coalesced around the use of NetCDF, and we are not proposing that change. There are ways to make all of this work with NetCDF.
Yeah, and the NetCDF, so much work has gone into the NetCDF data model and conventions that it would be significant to try to replicate all of that. This is really just data access.
And also to be clear, I mean, when you go to the demo website and bring up a layer, like select a layer from the map, that's actually reading from the node bucket. It's reading the NetCDF from the node bucket. So there's no actual data transformation happening there.
Correct. Yeah, it's reading the NetCDF from node. But if you tried to if you didn't go through the Czar process, it would take you, I don't know, maybe 3 times as long, right? Depending on the size. I do have a notebook kind of demonstrating that.
Cool. Any other questions? Well, so I had one question one topic you kind of touched on was, and some of the comparisons, I guess, between threads and XPublish is scalability. So I know that that is sort of one issue that people are running up against is just accessing some of these data sets through the existing threads, architectures that NOAA publishes. So things like just performance and subsetting and things like that. So how do you, I think you said it was addressed better, using the XPublish approach, but what happens if, like I go out and post this to 1,000 of my best friends, and they all try to, access the data set all at once. Not that I really can make that happen, but, how is the scalability problem changed, I guess, when you deploy a system like this and use XPublish kind of as the API, I guess.
Yeah, so I'd say it was the two different things. So XPublish doesn't do the aggregations. That's our Argo workflow, which kind of does that all asynchronously in the background. So that would be kind of, and that's pretty lightweight. I mean, those processes, kick off and complete very quickly, whereas threads crawls the file names, and in a bucket, it costs a lot of money reading the bucket every however many minutes you configured it for to figure out, and then it reads all the files and mashes them together. It's a significant amount of processing compared to the Kerchunk approach. And then for serving the data, so that's scalable because it's running on Kubernetes and it's running on Argo. And then for serving the data, I would say, like, this is all prototype code, right? This isn't. So I mentioned scalability is a thing that we are still looking at and want to work on. It works pretty quickly right now for almost no optimizations. But we know that we can do better, and that's part of what we're going to investigate when we look at these larger data sets like National Water Model. Is part of that work will be addressing some of the scalability. But we know that we are able to scale because we're not locked into like running on a specific server platform.
And one more thing is that because it's all working with, the way Threads works, right, is it kind of indexes and then keeps everything local to it, right? So everything's running in that one spot. So it scales vertically, not horizontally, right? So to scale Threads, you need to throw more horsepower at it. To scale this, you can scale horizontally, so you can just run as many XPublish. You can throw as many different XPublish servers at it as you want. Everything is on cloud storage, so you're not going to run into like database indexing problems or anything like that, or things getting out of sync between instances of XPublish. So you can just throw more servers at it instead of having to have one of the most powerful servers you can find. I think our thread server for the IUS EDS one is what are we up to now, Don? Like 128 gigs of RAM. Like it's ridiculous. Yeah.
All right, so there still needs to be some sort of clustering, but it's just much easier, I guess, to manage then.
Yeah, like you need a load balance. You'd want like a load balancer in front of it, but it's a different problem. But I think it's one in the cloud era, right? It's easier to scale, I think, this way than it is. Maybe not. Maybe it's easier just to pay for more stuff, but in general, it's easier just to spin up more instances.
Yeah, you can burst that particular instance to expand out as you need it on demand. So it's a different problem, but it seems pretty easy to solve in the cloud.
By using XPublish to build on top, or having XPublish build on top of X-Ray, we also get to use a lot of what that community's found, and specifically the Pangeo community has found for scaling the processing at that level, in addition to at the web server level. So we can scale out via Dask, and we're just starting to explore that as a community, which is it's pretty cool what we've been able to get already.
We're using Dask for the processing for all the 40-year reanalysis project that we were talking about before, right? So we've got to extract from this AdCert grid. I mean, the sample file we got has 70,000 time series points from a 40-year data set, right? So like doing that with Dask is a no-brainer, and it moves it along pretty quickly.
Okay, awesome. Any other questions or closing thoughts? We're just about at the bottom of the hour, so probably should wrap it up soon. But
if I could chime in with a quick thank you. We've got a awesome steering committee for this project. They're super engaged and super positive. And I won't name them all today, but we have 2 key members here today, Jim Temra and Tom Shika. So thanks to both of you for all your contributions and time on the steering committee, but also for coming to support this webinar today.
Yeah, if you get the chance, can you share some of these slides? Just to have them, if that is okay.
Sure.
Yes, definitely. If you can send me the slides afterwards, I'll share them around the group, at least our mailing list for the original distribution. So, and Philemon, I guess.
I don't know if my internet is good or bad, but anyway, yeah, a nice presentation, Jonathan. And if you notice the link that was provided by Philip, I think it's a good link. I said I have seen it, but I actually, when I glanced on it just now, I said, oh, I have not seen this one. So it's a good link. So take note of that, just in case those who thinks that they know about Kerchunk. This is a very nice publication here. Although there's one last statement, just in case. I know that Jonathan is very much in love with Kubernetes. He did say that it is the most trusted by the industry. I I don't trust Kubernetes yet, but it's getting there, Jonathan. Kubernetes is good, but I don't agree with that statement there, which you've said earlier. So anyway, nice presentation. Thanks a lot. Nice update.
Yeah, thanks. And I mean, I agree. Well, with any of these recommendations, right, there's trade-offs. So, you know, if Kubernetes isn't the platform, then, you know, you got to decide what you want to give up but what you want to get, right? So there are definitely alternatives. It is a beast. It's difficult to learn. It's taken me a lot of effort to get up to speed. But it is powerful, and for orchestrating and continuing to build out a containerized infrastructure, you know, there's really no competition right now.
Yeah, definitely a lot of moving pieces, and as far as the Kerchunk, you know, system goes, I feel like I understand it at some point, and then there's always something new that comes along that makes me feel like I don't completely understand it. So yeah, it's definitely can relate to yeah, some of the challenges and understanding conceptually how this all works. But I think it's, you know, so we just maybe to close, unless there are any other thoughts, we do have our DMAC annual meeting coming up in just about 3 months from now. So I think it'd be great to follow on this conversation with more discussion about kind of, you know, managing these type of large data sets and ways that IUs can help, and kind of where this should go from here. You know, that you have a great prototype that you set up and kind of a, you know, concept for a workflow for different idea for how to serve these data, and, you know, where do we go from here? So definitely opportunities for good discussions about that, in collaboration with NOD or, you know, other groups in NOAA that are looking for, you know, new ideas around this sort of problem. So anyway, thanks again, Jonathan and the rest of the RPS and Reaching for the Cloud project team folks who joined today. And thanks everyone for tuning in. I hope you got something out of this. And yeah, I guess, yeah, RPS, hopefully, if you're willing, I think there are some folks that would probably be interested in seeing the recording. So if we can figure out a way to share that, that would be awesome. We can chat about that afterwards, though. So anyway, thanks again, Jonathan, and hope to see you all again soon.
Yeah, thank you all.
Thanks, everyone.